A very good evening, friends. Welcome back. So we are going strong, day 4, and very heartening to note that the numbers are increasing. People are giving us comments. People are messaging us privately, giving us suggestions. 4,000 plus views have already come, and it is climbing. Really heartening to note that the efforts that the three of us are taking is of some use, and it is paying off. So we will continue, and definitely we will move on. So let's get back to it. It's just 30 minutes. So today is day 4, 13th of October, and we are going to start. We're going to continue from where we left off yesterday. We were discussing about pre-processing, so we'll get into the specifics of pre-processing. So my first question is to Mr. Sharath. If there are duplicates in your data, what do you do about it? And before you answer that, my other question is, why is duplicate such a big problem? Please.
Good evening, everyone, and thank you, Nathan. I'll directly jump into the question. When we deal with the data, we have to ensure that these duplicates are verified. And when I say duplicates, we are basically talking about the samples or the observations, or in other terms, we also call them as records or rows. Different terminologies are there. So when you have same row or record repeating again, then this is basically called as a duplicate entry. Now, when we talk about any specific characteristic with respect to the data set, so for example, I will talk about one column. The impact of the duplicate value in each and every column is also going to impact the overall distribution of that particular value or that particular column. Right from there, we will have the issues generating. When we talk about distribution, basically with respect to the characteristics of that particular column. More number of duplicates, that means the data becomes more consistent and the data's distribution is becoming very less narrow. It gets closer and closer to mean, you can say that. So this is one of the biggest problem that we will see with respect to the duplicate entries. And there are Python libraries which can very easily identify these duplicates and remove them. One specific library which is very commonly used is the duplicated function, which is just letting us know that these are duplicate values. And it returns a binary outcome saying whether a specific row is duplicated or not. And of course, we also have parameters which we can pass through this particular library or function, which can allow us on controlling on how we detect these duplicates. Now, if I want to remove these duplicates, if my business scenario demands me to eliminate them, then I would be using another function which is very similar to this duplicated function, which is called as drop_duplicates. It works exactly like the duplicated function. But in additional to that, it also removes the detected rows or samples. So that's basically how we handle the duplicate data method.
Thank you, Sharath, for that comprehensive answer. Barney, I would like you to add further, specifically to why duplicate is a problem. What we do with it, I think we are very clear. A little more on why duplicate is a problem. Can you please elaborate?
Sure, absolutely, Nathan. So when it comes to duplicates, handling duplicates in a data set, there are two things. One is duplicates with respect to the rows and duplicates with respect to the columns. Duplicates with respect to the rows or columns would just increase the data set. But the kind of information that you can glean from the data would still remain the same. For example, say we have a row which says person will default. That's one value. And then the other values pertaining to that specific row is, say, age 32, gender male, education graduate. If I have another another row, which is exactly the same, person will default, age 32, gender male, education graduate, then our model has already learned that specific information If it is going to be repeated multiple times from there on, it doesn't add any new information. So unnecessarily having it in your data set would increase the size of your data set and increase the time it takes for processing the data at no additional information that is gleaned. This is with respect to the duplicate rows. With respect to the duplicate columns, if you have a column called as, say, experience, and say you have another column called income, if these two are very strongly correlated, that means these two columns are more or less capturing the same kind of information. Hence, they both are capturing similar kind of information and they both have same kind of correlation. In this scenario, also having both which capture more or less the same information is not needed because it takes additional time to process those columns. So you can choose to have only one column rather than have both the columns. This is with respect to numeric columns. Then when it comes to columns, you can also have categorical columns. How do you decide whether you have categorical columns which are duplicates or not? For that, you have something called as value counts. For example, say you have a column called as gender, which has male and female, right? Somewhere else you have some other column related to gender, right? Or related to some other, say, for example, education, graduate, postgraduate, etc. Right? If you convert that into some other different format, say you do some kind of encoding on that data, then if you feel that more or less the categories and values are the same, then it warrants for some additional analysis to be performed on the data, right? So handling duplicates with respect to categorical data is not a walk in the park. It would take a lot of further analysis to be done. But with respect to continuous variables, it is pretty straightforward. You just look at the correlation of the two columns and then figure out, whether there are any columns which are capturing similar kind of information and get rid of one. Yeah, thank you.
Thank you, Barney. Thank you for that elaborate answer. And there's one small aspect, audience, that I picked up just now. Barney and Sharath both have been, using the same example from day one, which is Barney is always talking about the credit card fraudulent transactions, and Sharath is talking about that. Why is it important? Because your interview is not going to be for 4 days. It is going to be for 1-2 hours maximum. So if you have picked up something, if you keep correlating all the related questions or all the questions to that particular project or that particular case study that you have picked up, that proves that you have really done a lot of work on that. Even if they have not asked specifically, bring it to that. That is another takeaway I request the audience to pick up from here. All right, thank you so much, Sharath and Barney, for that elaborate and amazing answer. So let's now move on to the next question. This is again, I'll address it to Sharath first. So outlier is always considered as a troublemaker. All right, so I want to know, why is an outlier a troublemaker? Point number one. And I would also want to know how you've addressed the outliers, if they were in your database for the project that you worked on, and why did you use that particular method of treatment? So it's a three-part question. I'll just repeat. Why do you feel outlier is a troublemaker? What did you do when you had outliers in your database? And why did you do what you did with those outliers? Sharath, please.
Okay, thank you, Nitin. I'll try and cover all the three questions in the same answer. Try to elaborate my answer. I was working on dealing with the sales of the second-hand cars. Then we try to look into the data set. Always we try and look at the data set from a multiple variable perspective. That's basically a data frame in our business case. But when we are analyzing the data, we always have to start from one single column. This basically is a univariate analysis approach that we take. And when we talked about analyzing each and every characteristic for, let's say, the car that I'm talking about, that's the data set that I worked on. For example, mileage is one of the columns. The distribution is something that we look at. When I say distribution, we are basically talking about what are the various values of the mileage that I had with respect to my business scenario. The data set that I had is basically projecting that business case. So if, let's say, for example, my cars, but the data set, right, is projecting the examples of cars which have mileage somewhere around 8 kilometers per liter fuel. Till let's say 25 kilometers per liter. So this is my range. My data should be spreading in this. But if I have an exceptional case, for example, I'm dealing with a specific special car, for example, right? Let's assume that it is one of its kind, maybe Formula One vehicle. So the fuel efficiency of this vehicle could be completely different. Right? Now, this is not something which is regularly seen in the business case. It's abnormal case. This is going to impact the entire analysis that I'm going to do with respect to my data. So this is one of the reasons why I need to remove these exceptions, because they do not repeat regularly, and these are going to impact the entire analysis that I'm going to do for my business problem. So when we talk about the efficiency of the vehicle, so that we can correlate it to the cost, I need to ensure that it is in more of a generic scenario. Hence, we'll have to remove the or treat the exceptional cases. Now, how did I treat? We have many techniques, particularly in this example. I was dealing majority of the cases with respect to the mileage or fuel efficiency is basically my target variable, which is continuous in nature. And I was using an automation technique called Winsorization to deal with this outlier treatment. And in Winsorization, we have multiple, again, approaches. I specifically use the standard approach, which is used, which is called as IQR technique with 1.5 times as the fold. Before you ask, let me also add up. We do have other techniques. We can go with percentile technique, or we can go with Gaussian technique, which again deals with the normal distribution and all those points. But majority of the scenarios, the general practices with IQR methodology, and that's what I used. There are other techniques where we can also look into the influential observations, which is basically an example of talking about an exceptional case with respect to all the variables taken together. This is also an outlier for a multivariate data. For example, I'm talking about regularly used the cars, which are generally used by common public. But if I bring in a Formula One vehicle, that becomes a specialized car, especially with vehicle altogether. This vehicle details will be always exceptional considering all the factors. So this becomes an exceptional case. We basically call this as influential observation. Now we can also treat this using many techniques. One of the technique that I used is LOF technique, which is called as linear outlier factor. It also used for automatically to detect the outliers with respect to the entire data set. So these are the multiple things that I have worked on in treating the outliers.
Thank you so much, Sharad. Barney, what about your tryst with the outliers? How was your experience, and how
absolutely
you have created?
Yeah, sure. So within the project that I've worked upon, we figured out that outliers can be determined only for numeric columns. And there were two specific columns. One was age, another was income within the loan default prediction model. Within age, we had outliers on the extreme side, upper extreme. So we had a lot of senior citizens for that case. When we went back to our business to determine, hey, why is it that a lot of senior citizens are applying for the loan or have applied for the loan in the past, then they were saying that for senior citizens, we have a special interest rate when we disburse loan. And that worked out very well for us. A lot of senior citizens were applying for the loan. So when we check with them, would this strategy of marketing continue into the future? They told yes. And we had to retain the outliers in our analysis. We also had another column called as income. When it came to income, we have once again seen outliers on both the sides. On the lower extreme and the upper extreme, we had a few outliers. But out of 5 million records, approximately 10,000 were outliers. Probably 4,000 were at the lower end and 6,000 at the upper end, right? So then we could not possibly spend time investigating each and every outlier. So we have resorted to a technique called as Winsorization. And we have given a value called as alpha equal to 5%. What that means is, out of your complete data set, it will choose a 5th percentile value. Any value less than that would be converted to the 5th percentile value. Whatever be the value, you're going to replace it with the 5th percentile value on the lower extreme. And on the upper extreme, it would choose 95th percentile because you have chosen the alpha value as 5%. So any value which is greater than 95th percentile would be replaced with this 95th percentile value because we could not possibly get into each and every outlier and analyze why it was an outlier. So this is how we dealt with the outliers when it came to my project that I've dealt with. Thank you.
Thank you. Thank you, both of you. Well, so I'm quite excited about outliers because, outliers are, as they say, troublemakers, but outliers are there because of some reason. They are not a mistake. So my question is a follow-up question with reference to outliers. So what other techniques do you prefer, irrespective of the project that you worked on? And why is a particular technique your favorite? Now, I expect you to answer other than Winsorization because you've already chosen both of you. So anything else, I mean, why would you choose that or your next best technique and why?
All right. So there are many other techniques like we discussed, but if you ask me, my personal choice would be a manual way to handle this. Though it is laborious job, time-consuming job, but that gives me more control over dealing with these outliers. And I would probably look at 1.5 times the IQR technique. Again, it's my personal choice, a personal favorite. So I always go with this. But we can also try with other techniques like we have discussed. Why I use this is because the box plot technique that is used in Python is always by default using the same technique, and visualizing the data will become very easy. That's point number one. But from the information perspective, whenever we talk about outliers, these are generally the exceptional cases, as we discussed, abnormal cases. Now, if I take a more range as acceptable region, then I probably would not analyze some of the data which could be a potential outliers. So we can also talk about Q plus or minus 3 into IQR technique, but that 3 into IQR is going to give me a range which is increasing for accepting the regular values, right? Or treating the values as regular. If I use this technique, I might lose a lot of exceptional cases to be handled. So personal choice, manual technique, and I would always go with the 1.5 into IQR technique.
Barney, your words, your choices.
Well, absolutely. I second what Sharath has told. And when you have huge number of outliers where you possibly would not find time to analyze each and every outlier, then going with automatic way of dealing with outliers is the best way out. Having said that, if you have limited number of outliers, then it is always recommended that you spend your time on each and every outlier and understand why that is an outlier, because the wealth lies there in analyzing and understanding why that is an outlier. Yeah.
Thank you, both of you. Audience, the reason why I am, staying around outliers is in real life, when you are facing interviews, you will definitely be having a person from the, the background, data science background, and he would have faced a lot of problems. One of the biggest problem, the next question is going to be about the next biggest problem that is faced in real life scenarios. The biggest problem is about outliers and data quality issues, etc. So they are going to test you and know what all you know. If you're going to give them bookish responses with reference to what you know about outliers, etc., and not much with reference to experience, they may know what is your knowledge level. So this was the reason, this was the rationale behind why I was asking again and again about outliers. So next biggest problem that next biggest problem that we are going to discuss, which the companies face and which you are sure to ask questions on, is about missingness. All right. So Sharath, your experiences on missingness with your life, your practical or the project that you've worked on, and how did you address them? Go ahead. Looking at Sharath's smile itself, all the memories are coming. Please go ahead.
That's right. Missing values are really a troublesome activity. Treating them as a troublesome activity because we do not have the actual data. That's why it's called as missing data. And without the values, obviously we cannot apply any kind of machine learning algorithm directly on that particular observation. The biggest challenge is, even if I have one single cell or one single column value missing for a row, then the entire row values are gone, and I'll not be able to use a mathematical function. That's how computers work, and that's how we have to basically deal with the mathematical equations. Now, this is going to impact the entire analysis because a lot of data gets lost. Now, that is especially was very crucial in my project because I was working on with limited data points. I did not have too much of data to basically churn that numbers and try and bring up some pattern. So when we talk about these things, right? So yeah, scary situations, but yeah, that also gave me a lot of exposure on dealing with different approaches and trying out and seeing which method works and all that. So my approach, of course, was again going with the very basic things. I always try to keep things very simple, and to deal with the missing cells on the numeric values, numeric columns, I used mean imputation. Because again, I did not want to influence the information that is there in the column. If I wanted to impute a missing value, I could have put any value. For example, if the fuel efficiency column, which is basically the total number of kilometers per fuel, 1 liter fuel is being captured there, then I could have put a random number as 15 kilometers per liter if a specific cell is missing for one of the observations. But how sure are we if I randomly put a number? And it also impacts the entire information that I had in that particular column. So to ensure that I do not disturb the meaning of the column of the data that I received from the business, I simply calculated mean of the remaining available data and substituted that mean into that missing space. Now, the magic is that when we recalculate the average or mean of the columns, even after imputation, it doesn't change. That means I have not impacted my, basically the data. I have not influenced or changed the meaning of that data. This is specifically done for numeric columns. And for non-numeric columns, we used the constant imputation technique because with respect to the standards, majority of the data that we had was with respect to the cars or the vehicles, which are in the same range. Basically, their characteristics are very kind of a similar characteristics. So we wanted to go with a constant value for each column. For example, engine type. We wanted to stick to petrol vehicles. So whenever we had that column missing, we said, okay, let's assume that this is a petrol vehicle and then proceed further with analysis. So this is how we handled missing data, Mr. Nitin.
Thank you, Sharath. So yeah, it's pretty exciting dealing with missing values, and it's once you finally finish it off, it's like, wow, that was amazing. Could do it. I mean, before that, it is like a surgery that you are doing. I mean, it may seem very trivial for students out of in the training institute. Missingness, what is that? Just tuck 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 to this thing. But in production environment and real life kind of scenarios, it is a madhouse. Trust me on that. Barney, I would like to like you to add your pearls with reference to missingness.
Yep, absolutely, Nitin. So when it comes to missingness, if a value is missing in your data set, then one way to deal with that is do nothing. Just leave it as is. And then an entire row would get deleted. Even say you have 6 columns, and if one value is missing in one of the rows, the complete row will be deleted. That means you lose the remaining entries also. To address that, you need to first understand 3 things. The variance of missingness. Are the data missing at random? Or are the data missing not at random? Or are the data missing completely at random? So these are the 3 things that we need to remember. And we need to categorize each and every missing value with respect to whether they are missing at random, missing completely at random, or missing not at random. While it is difficult to go to each and every missing entry and then figure out whether a value is missing for at random or not at random or completely at random, we can look at the column and then figure out whether the values missing within that column are completely at random or not at random. Hey, what is the difference between these 3, right? Missing completely at random means a value is missing and you have no clue about that. For example, in the column called income, there might be a few values and people might miss that accidentally while providing their details. When they are filling their loan application, accidentally, because of some oversight, they missed out income randomly. That's completely at random. But then if they are purposefully not providing their income because their salary is extremely high, then it's called as missing not at random. That means people purposefully are not providing the details over there. So on one side, you have missing completely at random, where you cannot even determine why that value is missing. And on another side, you exactly know why the value is missing, which is missing not at random. And in between these 2, you have something called as missing at random, where there could be multiple reasons. Because the loan application was very lengthy and probably the income section was coming in towards the end and people were so tired that they didn't fill that. Could be one reason, right? Another reason is probably your question was, what is your per month salary that you're gaining before tax and after deducting your PF and PT, professional, tax. If questions of that kind are asked, maybe it puts a lot of mental strain on your brain. People cannot calculate that, or people chose not to calculate that and give you the income details. In those cases, it is missing at random. So there could be multiple reasons. You really don't know which reason to be applied, but certainly there is some reason to that. That's missing at random. Missing not at random, you perfectly know why they are not giving the detail. Missing completely at random, you really don't know anything on why that value is missing. Missing at random can have multiple reasons stacked to it. Only once you determine these things, only once you classify or categorize your missing values into these 3 sections, can you proceed further. Thank you.
Thank you so much, Bernie. Thank you, Sharath, for that amazing answer for the topic of missingness. And audience, trust me, what we only discussed about two things today. One was about outliers, and the other is about the missingness. And it is, if you are lucky, they do not ask you too many questions in interview, great. But please be thoroughly prepared about this, because this is going to haunt you. I'm literally using the word. It's going to haunt you for the rest of your life as a data scientist. All right. So if you get an opportunity to get answered in the interview, show them how much you know about it. If not, still be very well prepared on these two things and try to acquire as much knowledge as possible. So on that note, I'd like to wrap it up and give Barney a couple of seconds maybe to wrap it up. Barney, anything you would like to add today?
I think I've spoken enough for today, Nitin. I would rather request Sharath to conclude.
Yep. Thank you. Okay, so like I just wanted to put a conclusion note here for the session. And one thing I would definitely like to add is definitely these concepts are going to haunt us as a data scientist, because ultimately we are going to deal with data, and data comes in different forms from different sources. So one thing as a data scientist that you will have to be thorough is data pre-processing steps. And we don't have a standard process for this. So you'll have to be thorough for dealing with all these concepts, thoroughly upskill yourself into these concepts. With that, I would like to conclude.
Thank you, Sharath. Thank you, Barney. As always, please subscribe. Please click the bell icon. Please pass on this information to your friends. Let everybody gain the knowledge that we are trying to impart for everybody. Thank you so much.
Thank you all.